Hi guys, Larry Feldman with lesson number 2 on logarithms or logs. In this lesson I want to talk about the main properties of logs, and we're going to start with um, this property which says b to the log base b of x equals x. And this might look a little bit confusing at first, but we're going to do a substitution here, and I'm going to let me change some colors here. U equals log base b of x, and then coming back to our top equation, b to the, now I can write a u in here, since u equals log base b of x. I have log base b of x here. I can replace that with u, and continuing on, I have b to the u equals x, because this x just came down here. Now if I convert this to log form, I get log base b of x equals u. Just a standard conversion between exponential and log form. And then I continue on, log base b of x equals, I should have drawn this in green to be consistent, but see if I can cover that. Okay, that's the u. And using substitution, we know that this u is equal to log base b of x. Obviously a true statement. So this property is very, very important right there. And just to do a quick example, let's say I had 3, 3, 3, 3, 3, where are you? 3 to the log base 3 of 20. Well, according to this rule, the answer is 20. Notice this number and this number must be the same. So let me clear this. And actually, I want to do another example along the same lines. Let's say we do 3 to the log base 3 of 9. Well, we know from the equation that we proved on the previous screen that this is equal to 9. You know, this piece is x and that piece is x. In this case, we can actually show it to be true very easily, because log base 3 of 9, let me just switch colors real quick. This piece right here, the exponent, log base 3 of 9 we know is 2. Right? Log base 3 of 9 is 2, because 3 squared equals 9. So I can replace log base 3 of 9 with a 2, and then this 9 comes down, and I get 9 equals 9. So in this case, it's very easy to demonstrate that the property is true. Now, let's move on to some other properties. Log base b of x times y equals log base b of x plus log base b of y. This is very important. If you go from left to right, it's called expansion. And if you go from right to left, you're condensing. I'll just write it like this: expanding or expansion. I think I like the word expanding better. And this is condensing. condensing. Hopefully I spelled that right. And let's do a quick example. Log base 3 of 27 equals something. Now, you may already know the answer, but let's convert this to something else. Let's say we have log base 3 of 9 times 3, and I want to use the property above. So this becomes log base 3 of 9 plus log base 3 of 3. In other words, the 9 is here, the 3 is here. So we just applied this property above. Now log base 3 of 9 times 3, as we know, is 9 times 3 is 27. So the left side is log base 3 of 27, which is 3. 3 cubed is 27. Now what is log base 3 of 9? That's 2. 3 squared is 9. And log base 3 of 3 is 1. So we get 3 equals 3, which is true, obviously. And let me clear that and do another property. Log base b of x divided by y equals log base b of x minus log base b of y. And as an example, let's say we have log base b of, I don't know, 32 divided by 2. So according to this rule, log base, actually, I made a little mistake here. Instead of b, I meant to put a 2. Log base 2 of 32 divided by 2 equals log base 2 of 32 minus log base 2 of 2. This 32 is here. This 2 is here. And let's just show this to be true. This is log base 2 of 16, because 32 divided by 2 is 16. Log base 2 of 32 is 5, because 2 to the 5th equals 32. Log base 2 of 2 is 1. 2 to the 1st equals 2. Log base 2 of 16 is, you guessed it, 4. 2 to the 4th is 16. We get 4 equals 5 minus 1. 4 equals 4. Okay, so that works out. Now, let me clear that. Okay, let's do another property. Log base b of x to the n equals n times log base b of x. What we did here is we moved this exponent to the front, and it works in both directions. So if we start here, we can move the n to be an exponent of x. So let's do an example. Log base 5 of 25. What does this equal? Well, you probably can figure out quickly that the answer is 2. But let's write it a different way. Log base 5 of 5 squared, because 25 is 5 squared. Now, using the property above, I can move this 2 to the front. 2 times log base 5 of 5. Now this side, since it's log base 5 of 25, as I said, that's 2. 5 squared equals 2. 5 squared equals 25. This side is 2 times, and what is the log base 5 of 5? That's 1. 5 to the first equals 1. So we have 2 equals 2. Okay, we're in the home stretch of this lesson. Let me pose a problem to you. Let's say you were asked to solve a problem like this. 3 to the x equals 10. Well, we know x is not 2 because 3 squared is 9. And we know x is not 3 because 3 cubed is 27. But x must be somewhere in between. So we know x is between 2 and 3. Now, there are two main ways to use it to solve this using logs. And the first way is to use what's called log base 10. Most of you probably have seen calculators with the word log on it. Now that actually means log base 10 and whatever's in here. And if there's no base written, such as like this, it's assumed to be 10. So that's why this button is just log. It doesn't state a base because it's assumed to be 10. So using your calculator, well, first we can set it up by taking the log of both sides. So we have log of 3 to the x equals log of 10. Then we move the x to the front using the property that we covered a few minutes ago. And then we divide both sides by log of 3. They cancel on this side. X equals, now log base 10 of 10 is 1, and log base 10 of 3 is roughly 0.477 using a calculator. And these are actually approximations, which we denote using squiggly equal sign like this. And it's an approximation because we're rounding. And then if I take 1 divided by 0.477, I get 2.096. And this it's a good sign that we got a number like that because we knew the answer had to be between 2 and 3. And the other log function to use is natural log, ln, on your calculator typically, which means log base e of a. And e is a constant that is roughly 2.71, and I could talk for days about e because it's up there with pi in terms of importance. But e is an irrational number that goes on forever, and the digits never repeat a pattern. But using natural log, we would set it up the same exact way. Natural log of 3 to the x equals natural log of 10. We'd move x to the front. X natural log of 3 equals natural log of 10. Divide both sides by natural log of 3. And after those cancel, we get x equals natural log of 10 over natural log of 3. And if you use your calculator, believe it or not, you will get 2.096 roughly. Anyway, that's it for now. Please check out my website, www.lfeldman.com, for links to my math apps, which cover just about everything from algebra through calculus, with hundreds of examples, tutorials, and solvers. See you next time.